Record. Okay, so we already talked about chord and arc last time. So, and we talked about it during the warm-up. But one thing I want to point out here, remember this page, page 11, is really just for you. If you are looking at your online assignment and you're looking at a picture and you're like, I have no idea what's going on, it's really good to go back to this page and compare the pictures. And you're like, oh, that picture looks the same. What am I supposed to do? And read that. One thing I want to point out, which we just did that, so here we've got two congruent chords. So anytime you have two congruent chords, the arc they intercept are going to be congruent and vice versa. The rest of these, it's just a lot easier for me to just go over the examples than for me to explain this, because I know right when I start explaining it, your brains turn off, and then we go to these examples and you're like, okay. So let's move on. But it's really good to go back through and read those if you are confused. Oh, so nice. All right, well, one thing we have to make sure we notice here, some of these are arcs and some of these are segments. So like this is asking for arc WX. Arc WX is not 3.6 units long. Because every time I ask that, people say 3.6. No, it's asking about the arc for that. It's just slightly larger. No, it's going to be in degrees. Yes, how'd you know that? That's your genius. What are these two called? The other one. No, vertical, you're right. Vertical angles. You got it right, didn't you? I think you said vertical. And then, so those two are vertical angles, remember? Des Bryant X. And then the top and bottom are going to be congruent. And then for central angles, if it's a central angle, the arc is going to be the same. Hopefully we remember all this, because we did well on our quiz. So, alright, we've got 42 degrees. We can write that. 42. Alright, now we need YZ. Now it's the segment. Yeah! So the reason we knew that it's the same is because the arcs are the same. Alright, WZ. 9.2, easy. Alright, it's just the other side of that shape. It's going to be 9.2. This one right here, it's really just a review of what we did last time. It is asking for this arc, XY. Q? 138, yeah. So the reason we're able to do that is because we've got a diameter here, which cuts the circle in half, so you get 180 degrees. And then you take away, yeah, this piece right here, WX, which we don't want. We only want from X to Y. So take away 42, 138. And then we're going to cross off 5, because 5 and 6 are the exact same. So look at number 6. Oh no, we don't want that. There we go. Look at number 6. Sorry, I'm stalling. There we go. Alright, this is explained on the page before. Anytime you have a diameter and a chord, and they intersect at a right angle, it's a right angle because of that. You're still doing the same thing as we did last class. You have two choices. You're setting things equal or you're using Pythagorean theorem. One thing that throws people off is they see that right angle and they automatically think, oh, just Pythagorean theorem. Not in this case. This is the one where you're setting equal even if you see a right angle. Because if these are perpendicular, then each of the sides are going to be congruent. Is what that means. So you're going to set these equal to x plus 1, and you're going to solve for x. So the important part for this that will help you, I would suggest writing set equal there, just so when you look back, it just triggers your memory that you're supposed to set the two sides equal. And then you get x equals 6. All right. Now, we're going to go to number 7. Okay, here. This one you're going to do both. You're going to set equal and you're going to use Pythagorean theorem. What is the question asking for? It's what throws everyone off. Yeah, it says find the radius. Where is the radius? Is it on there? Is it drawn on there?
No. Not really.
No, it's not. So, a lot of people look at this and they're like, oh, okay, well, we know that's 3. Let's find that little baby piece. No, that's, like, impossible. Well, it's probably possible, but I don't know how. So what you have to do is connect the center to any of the 4 points, A, C, D, or F. I'm going to choose F. Doesn't matter which one you connect it to, and that becomes your radius. But you have to know that you're supposed to draw that in. You have to know that. So, all right, we're going to do 2 things. We're going to start with setting equal, and then we're going to use Pythagorean theorem on this triangle. But first, we have to figure out what is that length. So, what is the length of that line? So 3x plus 2 is just this chord. Both of these chords are going to be the same because they're both the same distance from the center of the circle. Circles are weird. There's just a lot of little things you have to remember with circles. None of this is hard. None of this is like, oh my gosh, it's so overwhelming, I don't know how to do it. It becomes overwhelming when there's just so much information. So you've got to make sure that every day you are learning what we're doing because we're always going to build upon it with circles. 3x plus 2 equals 5x minus 2. 2x equals 4. Alright. X equals 2. Great. Now we know what x is. We want to figure out what the length of EF is. So if we plug 3 times 2 plus 2, if we plug x in there, we're going to get 8. Is this 8? No. I see a lot of people messing up at that step right there. And they put 8 in and they're like, oh yeah, okay, put 8 in there, do Pythagorean theorem. Nope. Don't do that. And then, yeah, it's a triple. It's a triple. A 3, 4, what? Yeah, 5. It's like the one triple that people remember. Alright, so our answer there is 5. Yeah, 6, 8, 10. 9, 12, 15. 8, 15, 17. Remember them? 8, 15, 17. That's actually, that triple is on your homework. So if you remember that one, you can skip some steps. Alright, number 8. You're doing the exact same steps. I want you to do number 8 on your own. Uh-oh. Oh, no. Alright, if you're just staring at that problem and you have no idea what to do, start by drawing the radius. Pick any of the 4 points. Connect the center of the circle with any of the 4 points. With U, V, W, or X. Alright, so y'all notice that this is 10. 10 is going to go into Pythagorean theorem and not 20. If you put 20 in Pythagorean theorem, remember, you got to cut that in half. X is 3. You plug X in, you get 7. And then Pythagorean theorem gives you this. You cannot simplify 149, so that's your answer. Alright, are you done with that? Turn the page. Let's see, have that down. Okay. Alright, all these definitions, we're not going to write them down because they're all in here in bold. So if you ever don't know what any of these are, they're in here in bold. But an inscribed angle, we actually did this last class, and I'll point this out. See y'all. Did I do it on any of these? What a slacker. I think I did it on this one. Oh yes, this one. So we did this last class, remember when we had 30 and 30, and then it goes across? Those two angles go across, and the arc is twice as much. We're doing that today. So like this is 30, it's on the other side of the triangle, and then AB is 60. So you double 30 to get 60. That's what an inscribed angle is. So the difference is it's not in the center of the circle, it's on the edge of the circle. Okay? And then these two words are synonyms. Intercepts and subtends. You may see the word subtend, which you probably haven't seen before, but just know that it means intercept. Okay? They kind of go back and forth. I know, the English language, man. It's the worst. That's true. That is true. It's too deep. It's too deep for me. Alright, inscribed polygon. Right there, we drew one at the beginning of class. Reagan, do you have eyes in the back of your head? Yeah, I do. Okay, just wondering. We're good. Alright. An inscribed polygon. Remember the word inscribed? If you just switch it for inside, it's pretty much the same thing. So an inscribed polygon is inside a circle. Now that's deep. Right there. It's not. Yeah. So it's really these notes don't really take that long. Yep, last page of notes right here. I just find it a lot easier to explain it with the examples than with the pictures. All right. Angle A. When I explain this, how I want to start out is what is CB, that segment? C to B. It is your hypotenuse. What else is it called on a circle? Diameter. Okay. So it's a diameter, which is 180 degrees. All right. If we are trying to figure out angle A, then and A is an inscribed angle. A opens up to C, and it opens up to B. So it opens up to that arc CB. You cut 180 in half to figure out A. Because A is an inscribed angle. A is on the edge of the circle, so you see what arc it opens up to. It opens up to 180 degrees, cut it in half, you get 90. That's how that works. Angle C you can figure out because that's a triangle. Yes. Yeah. You just take these two angles away from 180, you get 62. This one right here, you do Pythagorean theorem, but we've done a lot of Pythagorean theorem, so that's the answer. Because I don't want to do it right now. So you use Pythagorean theorem for that. Alright, now we need to figure out AC and AB. So first things first, you've got to look at AC and you've got to see which angle is the inscribed angle that opens up to it. So AC, if you follow that back to the angle, it's going to open up, B opens up to it. B is 28 degrees. So you have to double B to get the arc. 28 times 2 is 56 degrees. All right. What about AB? What's AB's inscribed angle? 62, good, because C opens up to A and B. So 62 times 2 equals 124. Yeah, it's a right triangle. Alright. Number 6, you can probably figure this out just by looking at it. It says which two pairs are congruent angles, which two look alike. But A and what? Yeah, it's AD. You're so close every time. So A and D are the same, but I want you to know why they're the same so that you can understand what's going on. A and D are both inscribed angles that open up to BC. So A opens up to B, C. D opens up to B and C. If they both open up to the same arc, they have to be the same angle. All right. Angle B and angle C, it opens up to AD. They both open up to the same arc, so they have to be the same angle. That's how that works. All right. And then this one, we just did. What is that word we wrote? We had opposite angles. We had an inscribed polygon and opposite angles.
No, 80.
Were they the same? No, yeah, exactly. They were supplementary. Opposite angles are going to add up to 180. So angle B is going to be 180 minus 100. 80. And then angle A, all you have to do is take away the opposite angle from 180, whatever's left over. Okay. Alright, that's it. See, that did not take